Okay, welcome back to the next video. As you probably remember then from the previous video that you might have watched on internal energy, we've got here our definition for internal energy, and we highlighted these different sections in different colours. So we said we've got the kinetic energy of the particles and the potential energy of the particles. We also drew a nice little graph, which is here. And again, we've got the red sections, that's where the temperature is going up because the kinetic energy of the particles is going up. And we also wrote down that if you heat up an object, then two things can happen. One of them is to increase the temperature of the object, and one of them is to change the state. So in this video, we are focusing on the red section. So we're looking at this section where we are increasing the temperature of the object. So the kinetic energy of the particles is going up. So we're looking at that bit where the temperature increases. Okay, so you can see there then the title on your screen, specific heat capacity, and we'll come on in a minute to look at what that actually means. We'll look at a definition and look at the formula which you need to be able to use for specific heat capacity. But what I want to think about first of all, we had our graph a minute ago where we were looking at energy and putting energy into a system, which remember is an object or group of objects, and we're saying that the temperature is going to be going up in this case. And so let's think about, well, what things are going to affect the amount that the temperature goes up. So imagine you are heating a substance and we want to look at what factors. So we want to look at the factors affecting how much the temperature increases. And there are actually three things which are going to affect how much the temperature increases. Okay, and the first one, as you might expect, is the mass of the object. If you've got a higher mass of object and you put the same amount of energy in, obviously the temperature is going to go up by less. So the second factor here is just the amount of energy. So the amount of energy that you actually supply to that object is going to affect how much the temperature goes up. If you've got more energy, then the temperature will go up by a higher amount. And the final thing is just what material it is. Different materials will go up in temperature by a different amount, even if you've got the same mass and the same amount of energy going in. And actually, it is this bottom one, material. You might say, well, how do we actually measure that? How do we measure this property of a material? And that is what we call the specific heat capacity. So let's then have a look at the actual definition for specific heat capacity. Okay, so our definition then for specific heat capacity is the following. It is the amount of energy needed. You definitely need to get this written down somewhere. This is a really important definition that comes up a lot in exams. It's the amount of energy needed to raise the temperature of 1 kilogram of the substance by 1 degree C. Okay, and so it's actually a property of a material. So if you think about if you had 1 kilogram of that substance, for example, iron, say if I had 1 kilogram of iron, the amount of energy that I would need to put into that iron for its temperature to go up by 1 degree C, that is what we call the specific heat capacity. Now you might be able to look at that and actually work out what the formula is. Because we're looking at how much energy you need per kilogram per degree C, you might actually be able to work out how you would find that value. Because you take your energy, you divide it by the number of kilograms you've got, and you divide it by the amount of the amount the temperature's gone up by. However, that's not actually the version that is written in the formula sheet. And the good news is that this is one of the equations you are given in the exam. It's on your formula sheet, so you don't need to learn it. You just need to learn how to use it. So let me show you what that formula actually looks like on your equation sheet. Okay, let's actually write down then the formula for specific heat capacity. Now this is exactly as it appears on the formula sheet. So as I said a minute ago, you don't need to learn it, you just need to know how to use it. So we've got then, if we want to find, this is the way it's written, the change in thermal energy. So that's not written very clearly, change in thermal energy that's going to be equal to the mass multiplied by the specific heat capacity multiplied by the temperature change. Okay, now, like I've said before, you don't have to use the symbols at any point. The good thing about this one, it's quite a lot to write out, as you can see, and the symbols are given on the formula sheet. So actually, for this one, I probably would say using the symbols can be a good idea. The problem is they're not the most straightforward symbols. So actually, change in thermal energy, well, energy is given the letter E. However, because it's a change in energy, we put a Greek letter delta before it. That triangle just means change in. It's a delta. So delta E equals mass is M. Specific heat capacity is given the letter C. That's C for capacity, so it does kind of make sense. Now, temperature change, I'm afraid, is a little bit strange. Delta for change in, and it's given the symbol theta, like you might have seen for angles in maths. So there's our formula in symbol. So delta E, that's the change in thermal energy, equals mass M times specific heat capacity C times the temperature change, delta theta. Let's have a look at our units then. Hopefully you know already thermal energy is in joules because it's energy. Mass kilograms, you've met that one before. Temperature change degrees C, you've met that one before. Now specific heat capacity. You may also be looking at that and thinking, well, I can work out what it is, because specific heat capacity, if you rearrange this equation, would be energy divided by mass divided by temperature change. Going back to our original definition, the amount of energy needed to raise the temperature of 1 kilogram by 1 degree. So it's measured in joules per, so slash kilogram degrees C, like that. Now again, that's actually one that comes up quite a lot in exams, this unit, because it's a strange one. So make sure you learn that unit there. Right, let's have a look then at a couple of examples just to make sure you're happy with how to use it. Okay, there's example one. You might want to pause the video just to write it down. So how much energy does it take to raise 2 kilograms of water by 2 degrees C? And the specific heat capacity of water is 4,200 joules per kilogram degrees C. So always the same thing. I'm going to start off by writing out my formula. I will do it in symbols this time. Like I said, they're given on the formula sheet and it's a lot to write out if you do it in words. But if you'd rather do it in words, do. It's not a problem. You'll still get the marks. Okay, energy is what we're trying to work out. So delta E is what we're trying to find. Okay, mass is 2 times by C is specific heat capacity. So that's 4,200. Multiplied by delta theta, that's the change in temperature. There it is, 2 degrees. So we've got 2 times 4,200 times 2. Which, unless I've forgotten how to do maths, is 16,800 joules. Okay, and there is our answer then. Relatively simple. That would probably be, though, probably 3 marks in an exam, to be honest. Possibly 2, but as always, you would get a mark for substituting the numbers in, so make sure you're showing your working clearly. Okay, as long as you're happy with that one, then keep watching and we'll do one more. Okay, so there we go then. Here's a second example for us to have a quick look at. So I'll give you a second to read it. You might want to pause the video to write it down. So it takes 2 kilojoules of energy to increase the temperature of 2 kilograms of a substance by 5 degrees C. Find the specific heat capacity of the substance. So, just like before, we're going to put down our formula. So delta E, M times C times delta theta. Now, we've got to be a bit careful here. Energy, now we do actually know the amount of energy, the change in thermal energy this time. Remember, all of this is to do with temperature increasing, the thermal energy changing. It's here, look, 2 kilojoules. Now, 2 kilojoules, as hopefully you remember, is 2,000 joules. So I'm going to put 2,000 into there. Mass was 2 times specific heat capacity. That's what we're trying to find. So I'm just going to put that in as C there. And the change in temperature is here, look, 5 degrees. Just a sort of tip for exam questions, make sure that the numbers you're given are actually the change in temperature. You could be given 2 temperatures and you've got to work out the change. So just make sure you read the question super carefully. Okay, usual thing here then, we're going to simplify. So if we look on the right hand side, we've got 2 times 5, which is 10 times C. So to find our specific heat capacity, we're going to divide both sides by 10. And so that gives me an answer of 200. And then remembering our unit, joules per kilogram degrees C. And there's our answer. Right, so hopefully you can see then where we're coming from here. Questions about this often come up in terms of using the formula. There is also a practical to do with this, which we'll have a look at next time. But it's important you can use the formula, rearrange the formula like we've done here, to work out either the energy, or the mass, or the specific heat capacity, or the temperature change. And remember what we said at the start, this is all to do with you increasing the internal or thermal energy of our substance, and the temperature is increasing. All right, I think that's it for this topic then. I will see you on the next video when we will extend this further.